Hello, good afternoon, everyone. So it's about time that we're going to start our class. So let's start joining the class. As we wait for the others to join in, let's start by revising some of the things that we've been learning in the previous class. Okay, so good afternoon, everyone. How are you doing today? I hope you're doing fine. Can you go ahead and start describing some of the concepts that you remember from previous class, and then we'd keep on proceeding. You can write it in the chat section and also in the uh, Telegram. Good afternoon, everyone. I hope you're doing fine today. So we are starting off our class. Students are joining in. As we join in, let's all start by remembering some of the concepts that we were learning from previous class, and also confirm if you can hear me well. Just give me I can hear you, and if you don't really hear me, go ahead and say I cannot hear you. So, and also I can see that a lot of you are starting to explain the things that we've been learning. Haile Ab said, we have learned about transistors and Arduino Uno. Yeah, we did. But can you go ahead and explain what we learned about transistors? What are transistors? What is Arduino? And it's better to explain it than just mention the title. I really appreciate it, though. Okay, Highlab, we also tried mini project on Tinkercad, which is blinking a light. That's correct. We have seen about voltage, current, transistors, Arduino, and Arduino Uno. Okay, but can you guys go ahead and explain a bit about the titles that you are mentioning? What is the things that we've learned actually? Um, Kira said about evolution of computers, transistors, IC, Arduino, voltage, and current. That's correct. But I would like to listen to specific concepts someone have explained. Okay, this is a good explanation. Bonnie Black said, we have discussed about how totally mechanical machines were revolutionized into being electrical, what transistors are, their use, what about what Arduino is, and also we discussed about current and voltage. I really appreciate if you guys could actually explain the concepts that we've learned. For example, I like what Bonnie said regarding the revolutionization of mechanical to electrical devices. Likewise, what is Arduino actually? What is transistor? What is the difference between voltage and current? So let's go ahead and start writing about those. Okay, so I think we can start the class. Uh, I see that a lot of you have responded to the question. So you said, Bev Kerfat now said Arduino is a programmable microcontroller which is used in DIY projects to integrate sensors and different parts of a circuit. That's correct. And mm, Kira said we use transistors as switches and current voltage amplifiers. Transistors have emitter, base, and collector. The distance between the collector and the emitter transistor is known as the silicon gate. Excellent. Okay, so today we are going to proceed into learning embedded systems. The way that we're going to proceed actually is project-based learning. That's the best way to learn embedded systems. So I'm going to start off with Tinkercad. So I'm going to share you my screen. Okay, so I'm going to create a new activity, and maybe just as a revision, let me go through the LED project that we have done. I believe most of you have copied this and tried this. There's a lot of you already. That's good. That's good. At least like 30, 40 students have tried this. Maybe 50. So let me explain the code, how this thing actually in the Arduino programming it's done. So in the code section, there is two fundamental parts that you should always know. Oh, I was not presenting. I think you can see my screen now. Okay, so in the Arduino code, always there are two fundamental parts. The first one is, I don't know how to zoom the code. I believe you can see the code now. Yeah, so it's a bit too big. If medium is okay, we'd go with medium. So look, there are two loops. The first one is the first, necessarily the first one is not a loop. The first one is a setup. So this is a setup function. So whatever you write here is going to be there and done only once. It's going to be done only once. While anything that you write inside the void loop, it keeps on doing it again and again as long as the microcontroller is on. So the void inside the void setup, there are a couple of things that we do that we would like to set up only once and never do it again. But for the void loop, we do things that act based on situations, based on sensors, and they keep on reading the sensor value now and again. So this is the fundamental difference between the void loop and um, the void setup. So what we have learned previously in the previous class is that in the Arduino there are digital pins which you can see as from 0 to 13, which only reads between 0 and 1. It's either 0 or it's 1. And the other one is the analog pin. And the analog pin reads between 0 to 255. Okay, I'll explain this in a bit. So we have 6 analog pins, and this is the ground. This is VIN, forget it for now. It's used when you give additional voltage to your Arduino. And also we have 3.3 volt output and 5 volt output. And the additional ones like the wiggly sign or the approximity sign that you see in front of the digital pins is pulse width modulation. And this is TX-RX, which means transmitter and receiver. Whenever you want to connect something that transmits wirelessly or receives wirelessly, then this is the point that you're going to use. Or some protocols require TX-RX, then you use these two pins. Okay, so that's it about the Arduino. And the LED, you should never forget that we have two terminals. The first is the anode and the other is the cathode. So the cathode is the shorter pin while the anode is a longer pin. So the longer pin is positive while the shorter pin cathode is a negative. So we connect the negative into the ground and we connected the positive into pin 4. We put a resistor so that we don't burn out our transistor. So you can decide your value of your resistance by putting it here. So resistance is measured in ohm. So you can write kilo ohm, ohm, milliohm, mega ohm, whichever unit that you like. So for LED resistance, 220 ohm should be right. So once we have done this circuit, so whenever the signal is 1 from this pin 4, then we have 5 volt and this is going to turn on. Whenever we have 0 signal from pin 4, then it's going to turn off the LED. So in this manner, look here, we say digital write pin 4 high, which means, but before that, we set up the pin mode. So pin mode of 4 is output. Okay, we can also say input if that's actually an input pin. But necessarily for our case now, we are outputting voltage. So we're not inputting towards the Arduino. This is from the perspective of the Arduino. So I say output. So pin 4 is an output, and digital write pin 4 high. And after we make it high, for example, if I go ahead and comment this, okay, let me just delete this one and also this one. So if I run this code now, you see that the LED is turned on and you never see it turn off. But necessarily does turn off, but there is no specific moment of time that you see it turned off. It keeps on lighting back again. And since this is a simulator, it shows a perfect condition. Look, first it's digital write to pin 4 high, which is 5 volt. It turns it on, and there is no delay. It turns it on, then it turns it off, and it comes back to turn on. So since the first thing that we have done is to turn it on, so there is no delay for it to turn off, and it keeps on showing as if it's always on. But let's go ahead and put the delay after the low signal. You see that it was on, you have like flickering on moment, which is extremely minimalistic, and you don't really see it. So if we put a delay after each of the operation, then we can see that the on and off is doing well. Okay, so now I have explained about this code. I'm going to challenge you before I proceed to today's project that we're going to do. We're going to do something, a couple of things actually. So I want you to do the following. Bring in three LEDs, green, yellow, and red. Green, yellow, and red. 3 LEDs. And then I want you to start to flicker all the 3 LEDs together. Let me see you do that. Is the question clear? I can repeat it if you'd like. If you didn't understand, go ahead and say repeat. Some of you said, can you explain more? Like JJ, no. What do you want me to explain? What is the thing that you haven't understand? Until then, some of you who have understood, do you want me to repeat the question? I'm going to just repeat the question. So the question is, use 3 LEDs, green, yellow, and red, and let them blink all together once and blink off again. So the question is for you to put 3 LEDs and to turn it on and off all together. Yeah. So go ahead and do that. For some of you who haven't understood, I'm going to explain the code part. So the code does have 2 fundamental parts. By the way, this course is not about the code. I've said this several times. Go ahead and learn from our YouTube channel about Python programming, which gives you a fundamental understanding about programming, and then you can come back to this. So during the daytime, you can go ahead and revise about those. We hear this course, we are fundamentally dealing with the embedded systems and embedded systems programming generally, not programming or coding. We had other sections regarding this. You can always check out the videos from our YouTube channel. But necessarily, I'm going to explain it roughly as some of you start to do it. So any of you have completed the circuit and it's working, please go ahead and send a screenshot, or maybe if you can record your screen and send it in the Telegram group, that is something I'd really appreciate to see. Okay. Okay. So the code part does have two fundamental circuits. The first one is the setup, and the other one is the loop. So in the setup, what it actually does is it you give each pin as output, input, and so forth. So you say pin mode, and then you select the pin, and you say output or input or anything that you like. And sometimes you can always use variables like constant variables. You can always define them in the setup. And in the loop, in the void loop, what we do is something that runs again and again throughout the process of your Arduino active lifetime. So here, what we're trying to do is blink an LED. So to blink an LED, we have two fundamental features. The first one is to turn on the LED, and the next one is to turn off the LED. And in between them, we put delays so that the action of being on waits for a couple of times before it goes off again. So delay is counting the delay in milliseconds. So we have here 1000 millisecond, which necessarily means 1 second. So it turns on the LED, it waits for 1000 millisecond, and it turns off the LED and it waits for 1000 millisecond. Okay, so um, go ahead and start doing this, and then in a bit we're going to do it together. Is the question and explanation clear? If it's clear, anyone who understood, please give me a thumbs up or a sign or a something in the text section. So I can see that most of you have started to do it, which is great, and I really appreciate it. So, for example, this is a serious connection because you would like to turn all of them all together. You can do this. Also, you can use parallel and make the programming on off to work well. We even have a video. Okay, so I'm going to make it a bit challenging now. What you're going to do is turn first, like the Ethiopian flag, um, green first, and then when green turns off, then yellow turns off, then red. So green on, off, yellow on, off, red on, off. That's how you're going to proceed. So do this and send it out in the chat section. I'd really appreciate it if it's a video. It's very descriptive. Great, guys. Great. Keep on doing it. Let me see you do this challenge, and then we're going to do it together. Okay, so now that you've tried it, let's start working on this challenge altogether. So first thing that we need to do is bring in a couple of LEDs. Let me destroy this line. So this. So what we are looking for is 3 LEDs. You can always make a copy of this LED by you can just copy paste. Okay. control copy, control paste. That way we can make a copy of it, and I can click on it and give it a color of yellow, and this one give it a color of green. So the ground is the same thing, so I don't really have to do 3 grounds. So I can connect these grounds all together, I think. Maybe if it's not possible, what we can do is just use the usual way of taking the ground to the ground pin, but I'm going to show you in a bit how you can be able to actually use a breadboard. So also let's make this resistor like this, and let's bring one here. Let's make a copy of that and put it here, make a copy of that and put it here. So as you work on your circuit, make sure that it's also very much visible and appealing to understand, and also for you to trace your wrong deeds, or your errors. So make sure that you're actually very much doing the circuit in a very attractive and readable way. That's a very important skill. So, okay. Now, let's also give this third LED a ground. Let's move this a bit. And since these are grounds, let's make them black. They're all the same. And for these ones, let's give them a specific digital pins. So I'm going to give it to D1, first one. And by the way, the meaning for D is digital and A is analog. That's why we say A1, A2, until A5, and D1, D2 until D13 for the digital pins. Okay, so this is goes to digital pin 13. So let's give it a color of red because this pass is red, and do the same for this one. And for this one also it's yellow, so let's make the signal wire yellow, and for this let's keep it green, and let's change this black one into green. Okay, now doing the circuit is done. Let's proceed to the coding. So it's 1, 2, and 3. So 1 is green, 2 is yellow, and 3 is red. So now we have 3 pins. So I'm going to say pin mode. As you say pin mode, make sure that it's actually M is actually capital. Okay, this is a syntax. So pin 1 to 3. So let's say pin 2, output is completely capital. This is pin 1. We use a semicolon, and pin mode 3 is also an output. Now that done, what we're going to do is, for the first question I said, make them all turn on and make them all turn off. So pin 1 is high, and also we're going to say digital right. Pin 2 is also high, and digital right. Pin 3 is also high. Okay, and then we do the same thing. We copy this same code in digital write. I think I have a spelling error. Digital. Digital. So next, after 1000 millisecond, I'm going to say low, low, low for all the LEDs. So let's start simulating this. You can see that the LEDs are all turning on and off all together. Maybe you can go ahead and decrease the time. So for you to program it again, you need to stop the simulation and make it 500 maybe and 500. What's going to happen? Let's see. As you run it now, it flickers more faster. You can also give it like 100 and 100 to make it even flick more faster and faster. You can see that it's now flickering extremely faster. So the on time and the off time is very small. That's what's happening. Okay, so now this is turning them on and off all together. But if we like to actually turn on and off independently, here is the trick that we're going to do. So for the first one, let's say we only would like to turn on the the green one and keep the others low. So this is low. And all the application that has been done for the first case, we just copy that. And now instead of number one, which is green, we are going to light up number two, pin number two, that is yellow. So we're going to make this one high. And the last one is going to be the red. So for the red, this is going to be an error. I have to say it in capital. So this is going to be low, this is going to be low, and this is going to be high. So you see that in the first iteration, or in the first case, it's going to turn on LED 1 only, and next it's going to only turn on LED 2, and lastly it's going to turn on LED 3. Let's go ahead and simulate this. So you see that LED 1A turns on, then B, then C, but since it's extremely fast, we don't really actually see the off time. But I can go ahead and maximize this by making it 1 second so that you can identify whenever each one of them turns on and the other turns off. You see that this turns on, this, and it keeps on going through this cycle. So you see that the void loop, it keeps on running back again and again and again as long as the Arduino is on. So it never stops. It runs each line. As it completes the last line, it comes back to the first line to keep on executing this. Okay, so let me send you out the code in case you're having a challenge in the Tinkercad. Also this one. There you go for the circuit also. So maybe Nati or Khaled, can you go ahead and post the class code in any case if someone is having a challenge of joining in today? Okay, now as we've discussed about that, let's go ahead and start discussing about the uh, traffic light. So we're going to make a traffic light. So let's say this is day 2. So let's make a traffic light. So for the traffic light system, there are two things. I hope you can see my screen and what I'm writing on. And also my voice. If you have a challenge, always you can mention. So this is in a traffic light system, we have the pedestrian and we have the car. Okay, so for the car, there are 3 lights, and for the pedestrian, we have 2 lights. Let's actually make a table of this so that it's much easier to understand. So I'm going to say P for pedestrian and C for a car, or maybe car. And then we have the green light, we have the red light, we have, let's use colors, why not? So green light, and yellow light, and the final one is red light. Okay, and let's do this. Okay, so for the pedestrian, when the red light is on, when this is on, for the car, I think this table is not the way that to explain it, because it's a I think this is not a good way to explain it. I'm going to find a better and easier way. It's a concept that you know, but okay. For the car, when it's green, which means go on, and we're going to have for the pedestrian, it's going to be actually red. And for the car, when it's yellow, which means stop, or stop, or if you're actually passing, go ahead and go fast. So in this case, you never make the pedestrian move, so it's still going to be red. When it's red for the cars, then it's going to be green for the pedestrian. So this is the combination of a traffic light system. This is a combination of a traffic light system. So considering this, um, can you go ahead and implement these on Arduino using it's going to be 5 LEDs. We are going to have 2 LEDs for the pedestrian and 3 LEDs for the car, because for the pedestrian it's only red and green, but for the car it's green, yellow, and red. So can you go ahead and start doing that? Let's do it for 7 minutes, and then we're going to do it together. If my question is not clear, I can explain it. For those of you it's clear, please go ahead and start working. Okay? If you have questions, let me see your questions. Some of you are saying, please give us a PDF. We do have a book for this, and if you're willing to have it, then you can always buy it. But it's a package that you can buy along with the Arduino kits for now. But you can always come back to the video and search and understand more. Okay, so is the question clear? You're expected to do a traffic light system which resembles this. So whenever it's green here, it's going to be red on the pedestrian side. Whenever it's yellow on the car side, it's going to be red on the pedestrian side. And whenever it's red on the car side, it's going to be so it's acting up. Anyways, I could it made a copy. Really, previous change undone is. Anyways, forget about it. Um, so you just when the car is red, it's going to be green. So go ahead and start implementing this using Arduino and coding using Tinkercad. And then we're going to do it together. So I can see that a couple of you have started experimenting on this. Let's see some of the works that have been done. So there is a circuit of two wires with only two pins that are connected together. Yeah, that makes sense. You can connect it together. That's possible. This is also another circuit with another circuit with five pins. This is also possible thing that you can do. And someone have even used a video to explain this. I really appreciate it. That's great. So let's do it together. Let's do it together. So let me go to the Arduino page here. Okay. So to always go back, you can press the Tinkercad icon. So it takes you back. I'm now going to create a new design in data circuit, and you're going to add, let's name it to be traffic light. And we need Arduino. I saw a question that says, which Arduino is better, the Arduino Mega or the Arduino Uno? So it really depends on what you're doing. So Arduino Uno, it's quite a very important Arduino for beginners, but also you can be able to make a lot of projects with Arduino Uno. Arduino Mega is when you need a lot of pins and everything else. So if you're starting your Arduino journey, I really recommend you use Uno if you would like to buy. Okay, so these are our LEDs. Let me go ahead and copy them into a couple of parts. So this is another one, and this is another one, this is another one. Maybe this is going to be green. So, and also the last one for the pedestrian side. By the way, there is a way that you can add text, like you can press this and you can write here, car. Okay. You can put car here and you can say pedestrian here. So this one is going to be, one of it is going to be green and the other is yellow. Here also we have green and yellow. So considering some of you do not have a coding background, I'm going to write a very simple way of writing the code, but there is, of course, a lot of way that you can optimize your code. So as I start to connect the circuit, okay, this is 1 kilo ohm resistance and it's a bit too big, so I'm going to make it ohms, and 220 is actually enough. As I do this, uh, it's actually much better if we have a breadboard. So let me start to explain about breadboards. So look, um, breadboards are like makes actually have a connection of as such. So horizontally, all the points on the breadboard actually are connected or short circuited inside of it, and of the vertical lines in the ABCD path are different points. So this is the same one, but this line and this other line is a different one. And there is a separation in between. And also you can see that the horizontal line at the beginning and the end of the breadboard are also connected all together. Okay, but here there is a disconnection. So all the horizontal lines, the 5 points that you see here are exactly the same point. So if I put a pin at A and any other wire at B, C, D, or E, it's going to actually short circuit them and make the connection to be all together. So in that manner, I'm going to bring in a breadboard. So this is a smaller breadboard that I'm going to use, but you can always use a bigger breadboard if you wish to. But one thing that you need to remind is when you're using, look, in a breadboard, if it even shows you how the connection is. If I zoom in, look, when I approach in one of it, it shows you that it's all connected together. If I try and hover over this, it shows me that all these lines are connected together. But every horizontal line in these 5 liners for 5 points are actually different. So sometimes you could run into a challenge that in this bigger breadboard, this separation exists. So all the points here are different from the points down here. So keep in mind about that. Okay, that said, let me delete this breadboard as I don't want it. But for this one, look what I'm going to do. So I'm going to bring in the ground wire and connect it to this negative rail. And I'm going to give it a color of black, which means all the points here are actually uh, ground. And I'm going to bring 5 volts and I am going to connect it to this one. And I'm going to make this one red. So I can just pull up from these points and connect it to any of my resistors. So I'm going to make this black and I just can keep on connecting the points very easily. I don't have to now travel all the way to the resistor to do this, all the way to the Arduino to do this. I can keep on connecting this to the ground because ground is the same for every device that you're going to actually um, connect. Okay, that said, now let's start connecting the signals. So for the green ones, Let's go here and also connect it here. The other point, we can start this with 1, and the other green also from the pedestrian side. Go 1, 2, 3, and we can start the pedestrian side to be at 4. Oh, and let's go for yellow. To pin 2, and let's go for red. Or pin 5. And then now we can start to code. There is nothing to simulate actually, so I'm going to say text. Okay, now that been done, you can use like words instead of variable numbers to avoid confusion. So using C++ programming to create an integer value, you say just int, and then you give the name of that variable. For example, I'm going to say car green to mean CG is car green, and I'm going to give it a value of car green is actually at 1, and int car yellow, I'm going to make it 2, and int car red is equals to 3. So now I can use only the variables. Likewise, for the pedestrian, I'm going to say pedestrian green. It's going to be 4, right? Pedestrian green is at 4, and int pedestrian red is equals to 5. So don't forget about the semicolon. And here, what I'm going to say is pin mode car green now, not actually 1, because I've assigned the value or the variable with the number 1. So I'm going to keep on copying this for all the 5 of it. So car yellow, car green, car, this is car red, and pedestrian green, pedestrian yellow. They are all outputs. Oops, I don't know why I started simulating. But it says we have an error. So in the void setup. Well, pedestrian yellow is not declared. That is what it's saying. We have pedestrian red. And then, so next up, what we're going to do is we're going to give it a digital write. So I'm going to say digital write car green, car green. So for all the situation, we put the value for each of it. This is the very easy way of programming, but you could have a couple of options. So I'm going to put every of the possible LEDs, and I'm going to start to mimic the situation that we've been discussing previously. So there is car green, yellow, and red, and pedestrian green and pedestrian yellow. So when car is green, then yellow is low, also low. Pedestrian green is low. Pedestrian, this is pedestrian red. Pedestrian red is high. Let's copy this after each iteration. After each LED turns on, we have 100 millisecond delay, and then for the next one, what's going to turn on is going to be yellow for the car. So we're going to make this high and low for all the things except the pedestrian green. The pedestrian is still on red. Let's copy this again. So now the car have stopped. That's red. Red is high. And for the pedestrian, the green is going to be high, while the red is going to be low. And the last iteration is for the car, it's going to go green again. So necessarily what means is it's going to repeat what it have done previously. Okay, so let's run this code and see what happens. So you can see that green and red, yellow, then green, it keeps on doing this path. So maybe I can extend the time to be more so that it's much more visible. So as a homework, I'm going to give you one thing. So you see that when it's, actually let me make it 3000 so that it's much easier for me to explain it. Okay. So you see now when this lights up, then it's red. So can you go ahead and make this yellow flicker 5 times? Flicker, 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 flicker 5 times before it goes red for the cars. So flicker 5 times before it goes red. Okay, this is going to be your homework. So green, then yellow does not light up just as this, but it keeps on flickering 5 times before it actually turns red. So I'm going to copy the code and send it to you in the Telegram group, and also in the chats in the Telegram group necessarily, so that you can always do it again. But necessarily you can always do it from the classroom, which is available in Tinkercad. There you go. I have sent it there. So Okay, so now we've learned about LED lighting. Let's do one more project for today. Dave, can you also, maybe Dave or Nati, one of you, can you send out the attendance for today so that they can start to fill in the attendance? As you guys start to send out the attendance, I'm going to proceed on teaching you the next topics. So these are some things that we've discussed. Digital write, pin mode, delay. So delay is something that we use to delay whatever action that has been done um, in the uh, in the previous code. So this is about breadboards, and we also saw about digital pins, power pins, and analog pins. That's why we have A in front of analog pins and D in front of digital pins. But sometimes in digital pins you don't see D in some of the Arduino, but you do see it in others. Okay, so we also saw pin mode. Pin mode is setting up the mode of that specific pin. Is it on or off? That's what we're going to set up. And digital write is writing any value that we like for that specific number or variable, and then we give it a signal, high or low. And delay we can use in milliseconds. But there are also other types of delay in microseconds that you can be using. Okay, I'm going to teach you now about push buttons, so so that you can be able to actually use buttons to turn your LEDs on and off, or your any of your sensors to go on and off. So um, a quiz has been sent out in the main channel of Infnova Technologies and also in the Telegram section. So we require you to go and answer it in the Telegram channel, not in the community channel. So for you to find that, in case you haven't joined the channel, um, I'm going to send you the link tree. So you have to either answer it in the Telegram channel or or in the LinkedIn, whichever you prefer. So I have sent you a link tree. So go ahead and click for the link tree to check out the exercise. So let's do this for 3 minutes, and then we'll proceed to push down and pull up resistors. So how many of you have gotten 3 out of 3? I would like to actually know. You can also do the answers in our LinkedIn page. You can also uh, follow us in whichever way that you actually prefer. Okay, I can see that a lot of you are answering the questions. Um, yeah, that's good. I think most of you are answering it well. I mean, above 70% or so are getting it correctly. Good. Okay, now let's proceed. So pull up and pull down resistors. So pull up resistors, what they do is actually um, look. Whenever you press the switch, what it means is this is a switch, and when it's pressed, it means it's going to connect. If it's not, it's going to be open circuit. In the behavior of current that you should always know is that it always selects the path that is much easier for it to flow the current. So if there is a big resistance, then it's never going to go through that direction. Let's see in the case of here. For example, it was 5 volt here. It goes through the resistor. The resistor is, whenever it's a pull up or a pull down resistor, it's going to be huge amount of resistor in megawatts, in mega ohms. So this is a big resistance. So power goes here through here and comes at this point. So at this point, it's going to make a choice. It either goes to the microcontroller or to the ground. So the ground is the most easiest path for the current to go than the microcontroller, because the microcontroller by itself is, it has a couple of resistance when you consider grounding. So ground is the most appropriate choice that it's going to take, because current does not choose a resistance path. So if we turn on this switch, what's going to happen is the current never goes to the microcontroller but directly flows to the ground. But if it's open, then it's going to pull it up to 5 volts. That's why we call it a pull-up resistor, this resistor. So if you don't turn on or push that button, it's always going to be high at 5. When you push that button, it's going to be low, and you're going to read the low signal, and you can manipulate it for any of your purpose. Likewise, um, for the pull down resistor, look, the current is coming from 5 volt, it goes down. So as I've said, it makes a choice of low resistance. And pull up and pull down resistance are huge amount of resistance with mega ohms of resistance. So at this point, it's going to make a choice between this path or this path. So it's going to choose which one. If this switch is, if it's open, necessarily we don't have a current, and it's going to be pulled down. The microcontroller is going to actually read 0. But when the switch is actually turned on, then that 5 volt is going to come here at this point, and which path is it going to actually select? The ground or the microcontroller when it's switched on? I would like to hear from you in the chat section or in the Telegram group, whichever you fits you well. Okay. It goes to the ground. Really? Someone said, okay, let me see your answers. Francis, you said please give the code here. I could do that, but necessarily it's better in the Telegram. That's why I'm sending it there, because you can always reference it much easily. So please go to the Telegram and you can find it. So Birhanu said microcontroller because there is less resistance. That's pretty much it. Because the microcontroller does have a lower resistance than the pull down resistor, it's going to choose the path with a lower resistance, and it's going to go here. So whenever the switch is on, we're going to read 5 volt. Whenever the switch is off, we're going to read 0 volt. But this is different for the case of pull up. For pull up, when the switch is off, actually we're reading 5 volts. So depending on whichever situation that you would like, you'd apply it for your case. So this one is known as normally on because it's 5 voltage. And the other one, the pull down, is known as normally off. So let me do you one more exercise with this, and then we're going to proceed. Okay, let's create a new one. Something about push buttons also that have forgot to mention. I think it was on the slide, but I don't know how I forgot. Okay, so push buttons, they connect diagonally. So point 1 and point 3, these ones are connected, they're short circuited. So if you connect something in these two lines, then necessarily they are short, you're going to burn out something else. But the way that you can connect is diagonally. Point 1 with 4, or point 3 with 2. That's the way that you can use it. Okay, maybe you can use 1 and 2 also, or 3 and 4, but not in this direction, which they are already short-circuited. But the best way is just to use diagonal connections. That said, let me create another project. Circuit. Create a design. Okay. Let's create one LED, one Uno. Let's have resistor. Let's also have a breadboard. Okay. So now let's start making the connection. Also a push button. Okay, we can connect the push buttons in this manner, so that we have all the 4 points. You can see here, all the 4 points are connected. Oops. Oh boy. I don't know if it's my connection, things are going slower. Okay, I think it's better now. So for us to have a better visibility, I'm going to move this upwards, or maybe here. Okay, so we have our resistance here. So we have our resistor here, and we can connect it by turning it around to one of the legs here, and so we're going to use the other leg to actually do the connection. So we're going to put ground to the ground pin and 5 volts to the 5-volt pin. Let's make our lines straight. Okay, so this is 5 volt and this is ground. Okay, so let's connect one of these lines here with 5 volts. So necessarily this line is this one. I can go ahead and connect it with the 5 volt. Let's give it a color of red. So I'm trying to do pull down resistor. Okay, so pull down means it's always pulled down to the ground. So the resistance here is connected to the ground from the circuit that you can remember from previous one. It's black. So the resistor is on the ground and the other pin is connected uh, to the 5 volt. So you can either connect it diagonally, as I've said, or you can always also connect it uh, in this direction, never in the horizontal, in the vertical direction. So now that done, we can connect with the LED. Whenever this signal is on, then we can manipulate whatever we do with the LED. But we need to be able to read this signal. So whenever we have voltage happening, like 5 voltage, then we're going to read the with one of the pins. So I'm going to connect it with pin 1. And I'm going to put an LED here. As usual, the ground goes for ground. And I'm going to make it go for one of the pins. Let's say digital pin 5. And let me give it a color of green. Okay, so for this signal, let's give it a color of orange. Voila. Okay, now let's start coding. So here, some of the components that we have, pin mode 1 and pin 5. So for pin 1, we're going to have as an input, because we're trying to read the 5 volt if it's pressed and the pull down resistor is, the switch is on or off. So for we can say push button or just button, and I can say for button it's connected to pin 1. I need to say int because it's C++, and int I'm going to say LED. LED is in pin 5. So pin mode for pin for LED is output, but pin mode for the button is input. Okay, because we're expecting 5 volts or 0 volts from the pull down resistor. So now let's remove this, and what we're going to say is in the loop, maybe we can start by creating one variable int, and let's call that button state. What is the state of the button? So I'm going to say digital read, and give it a value of which pin it's going to read. So it's necessarily reading from the button pin. And next up, I'm going to apply this to LED. But before that, we need to check if it's actually working. So to do this, there is something important that we use in Arduino programming. It's known as the serial input, serial read. So serial begin, I can say 9600. This is a way that you can serially see the input and the output from the Arduino. You would understand it more in just a few seconds. And then I'm going to say serial dot print line and whatever the state of the button is. So serial.println button state. And for us to visualize it well, I'm going to delay it for 1 millisecond. And let's run this. And in your, there is an error because I have forgotten a semicolon. In your Tinkercad, there is serial monitor here, and it shows the value that it is reading. Because it's a pull down resistor, it's always reading 0. But let's see what happens when I push the button. Ouch! It blew. It blew. So had it been an actual Arduino, this means that we have burned it. We have burned it. This resistance, it's only 1 kilo ohm, maybe. Let's stop the simulation. Increase it to maybe 10 kilo ohms. Oh, still burning. Let's check our circuit. So this is around, it's connected to 5 volts. And maybe let's use the diagonal one. I don't know if it's mandatory. Let's use the diagonal one. So resistance 5 volts, and use this to be here. So now we have diagonally connected it. So the 5 volt comes in, it either chooses to go through here or through the microcontroller when you turn it on. It still burns it. It's using maybe a perfect condition. Let's add one resistor. This shouldn't be the case in actual Arduino, okay? This is, I think this is something due to simulation that's happening. Had it been an actual Arduino, this should work. For those of you who are working with actual Arduino, then should be okay. I'm actually changing also the pin to pin 2. And go on connecting it here. Let's start simulation. Before that, let's give it a very small resistance, maybe 220 ohm. And for this one, let's make it maybe 100 kilo ohm. Let's start the simulation. It's not burning now. Okay, you can press on the code and on the serial monitor. Let's see what happens. I really don't know why this is not working. But instead, maybe it should be honestly 0 resistance, but I shouldn't put a resistor. I never changed the pin. So the button is actually on pin 2. Okay, maybe to save our time, I don't know what is really missing. I'll just come up to this tomorrow, but I think you understand the fundamental concept of what it's doing. So we'll do it tomorrow because the time is almost going away, and we have a quiz. And so let's proceed to the quiz, and then let me figure this out as you take the quiz. And also let me describe about the quiz. Dave, are we good with the quiz? So before we go to the quiz, there is one important thing that I would like to mention regarding the project development. So we're going to team you up into groups, like maybe 4 or 5 groups, and then you're going to do a certain project which you're going to present it on Friday, and it's going to be very helpful for you and also for your certification. So we're going to send out this form also in the Telegram group. regarding the grouping. So um, make sure that you fill in the grouping form. I'm going to send you the link for the grouping form, and you start to fill that until tomorrow. Make sure that everyone fills in this form, otherwise we cannot assign you to any of the specific groups. So there you go, I have sent it in the Telegram group, and also I'm going to do it in the chat section. So get ready also for your quiz. We'd send out the quiz in just 2 minutes. So Amin said, yeah, the grouping is the grouping random. Yeah, we're going to do it. We're going to make the grouping random. We're going to make the grouping random. Yeah, so go ahead and start filling in the form for the grouping, and we'll group you in any of the groups. So one thing that I haven't mentioned maybe is that throughout the training, please make sure that you use only single form, single email address and the same name. Especially with your email, please don't go ahead and start using different types of emails. It's very vital you use one email, because for every email that you use, we are going to consider you different person, and that's going to be very bad for your grade. You know, we consider one of the exam, probably you've missed one of the exams. So please make sure that you are sure you're using only one uh, one email address. Okay, so start filling this. As you fill this, Dave is going to send out in just 2 minutes your quiz. So for those of you who have already completed the exam, I have figured out the connection issue that I was making. So I was connecting the resistor to the down part of the switch, which I should have done on the other side of the switch actually. That was the main problem. So now you can see that it's running and it's continuously pulled down to zero. Whenever I press the button, you see that the serial monitor changed to 1. I'm going to go through this explaining a lot tomorrow, but for now, if you'd like to check, I'm going to send you only the code regarding it doesn't include about this the LED, and you can always check it out from the activity section. Okay, so proceed to your quiz. So for your quiz, you're remaining with above 6 minutes. Please go ahead and start doing your quiz. It will be closed after the timer ends. Okay, good luck. And yeah, anyone who have completed this, you can keep on chatting and asking questions for a couple of minutes, and then also revise so that for tomorrow we're going to keep on learning other things also. Okay. So, okay, time is up for the quiz. So, we'll wait you for a couple of minutes for those of you who are having internet challenge who just mentioned to me on the personal chat. Um, so you can keep on discussing a bit, and also try to discuss between yourselves and your fellow learners, to discuss more about what we've learned today. And for tomorrow, make sure that you read and practice everything that we've done today, because it could be some new concepts also. Okay, have a good night. It was a pleasure having you. Au revoir.